Hello and welcome. This video will take you through some example questions from the Amazon MLS C01 AWS Certified Machine Learning Specialty Exam. After that, we'll examine the correct answers and have a discussion about them. Let's take a look at the initial question. What is the purpose of feature engineering in machine learning? To create new predictor variables from existing data. To remove unnecessary columns from the dataset. To train the machine learning model. To evaluate the performance of the model. The accurate response is to create new predictor variables from existing data. Let's now explore why this answer is correct. Feature engineering in machine learning involves transforming raw data into a format that is more suitable for modeling. By creating new predictor variables from existing data, the goal is to improve the performance of the machine learning model by providing it with more relevant and informative inputs. This process can include tasks such as scaling, normalization, encoding categorical variables, and creating interaction terms. Ultimately, feature engineering helps the model better understand the patterns and relationships within the data, leading to more accurate predictions or classifications. Removing unnecessary columns or evaluating model performance are important steps in the machine learning pipeline, but the primary purpose of feature engineering is to enhance the quality of the input data for more effective model training. Alright, here comes the next question. Which of the following techniques can be used for data preprocessing and feature engineering in machine learning? Principal component analysis, PCA. One-hot encoding, mean imputation. Recursive feature elimination, RFE. The right answer is one-hot encoding. Let's now explore why this answer is correct. One-hot encoding is a technique used in data preprocessing and feature engineering in machine learning. It is used to convert categorical variables into a numerical format that can be used by machine learning algorithms. This technique works by creating a binary vector for each category within the variable, assigning a 1 for the category present and 0 for the others. One-hot encoding is particularly useful when dealing with categorical variables with no inherent order, ensuring that the machine learning model can interpret these variables accurately. By using one-hot encoding, it helps to improve the performance and accuracy of machine learning models by providing meaningful and usable inputs for the algorithms to process. Alright, moving on to the next question. Which of the following supervised learning algorithms is designed for classification tasks? Linear regression, naive Bayes, k-means clustering. Pause and reflect on the answer before it is disclosed. The accurate response is naive Bayes. Let's now explore why this answer is the right one. Naive Bayes is the supervised learning algorithm designed specifically for classification tasks. It is a probabilistic algorithm that makes use of Bayes' theorem for classification by assuming independence between features. Naive Bayes is particularly effective for text classification tasks, such as spam filtering or sentiment analysis, as it works well with high-dimensional data. This algorithm calculates the probability of a data point belonging to a particular class based on the prior probability and likelihood of the features. By choosing the class with the highest probability, naive Bayes can accurately classify data into different categories. Overall, naive Bayes is a versatile and efficient algorithm for classification tasks, making it a valuable tool in machine learning applications. Alright, here is the following question. Which of the following unsupervised learning algorithms is used for density estimation and anomaly detection? K-means clustering, Gaussian mixture model, principal component analysis, isolation forest. Please pause and consider the answer before we share it. The accurate response is Gaussian mixture model. Let us now examine why this answer is the right one. The Gaussian mixture model, GMM, is the unsupervised learning algorithm used for density estimation and anomaly detection. It assumes that the data is generated from a mixture of Gaussian distributions, allowing it to model complex patterns in the data. By identifying the probability of each data point belonging to each Gaussian distribution, GMM can be used to estimate the density of data points in a given space. This makes it particularly useful for detecting anomalies or outliers in a dataset by flagging data points that have low probabilities of belonging to any of the Gaussian components. Therefore, GMM is a powerful tool for identifying unusual patterns or events within a dataset that may not conform to normal behavior. Alright, moving on to the next question. When evaluating a classification model, which metric should be used to measure the balance between precision and recall? F1 score, accuracy, confusion matrix, ROC AUC. The accurate response is F1 score. Let's now determine why this answer is correct. The F1 score should be used to measure the balance between precision and recall when evaluating a classification model. The F1 score takes into account both precision, the number of true positive results divided by the number of all positive results, and recall, the number of true positive results divided by the number of positive results that should have been returned. This metric provides a single value that represents a balance between precision and recall, making it useful when both metrics are important in evaluating the performance of a classification model. By taking the harmonic mean of precision and recall, the F1 score helps to avoid situations where one metric is high while the other is low, providing a more comprehensive evaluation of the model's performance. Alright, here comes the next question. What are the different ways to deploy a machine learning model on AWS? Amazon SageMaker, AWS Lambda, Amazon EC2, Container Service, ECS, all of the above. The accurate response is all of the above. Let's now explore why this answer is correct. When deploying a machine learning model on AWS, there are various options available. Amazon SageMaker is a fully managed service that provides everything needed to build, train, and deploy machine learning models. AWS Lambda allows you to run code without provisioning or managing servers, which can be used to deploy models as serverless functions. Amazon EC2 provides resizable compute capacity in the cloud, suitable for deploying machine learning models on virtual servers. The Container Service, ECS, allows you to run applications in Docker containers, providing a scalable and flexible way to deploy models. Therefore, the correct answer is all of the above, as each option offers a different approach to deploying machine learning models on AWS. Alright, the next question is, which of the following techniques can help in optimizing and tuning machine learning models? Grid search, random search, Bayesian optimization, genetic algorithms. Pause and reflect on the answer before we disclose it. The accurate answer is Bayesian optimization. Let's now examine why this is the correct answer. Bayesian optimization is a powerful technique for optimizing and tuning machine learning models. It is an iterative method that uses probabilistic models to efficiently search for the optimal set of hyperparameters. By utilizing a surrogate model to model the objective function, Bayesian optimization can make informed decisions on which hyperparameters to try next, ultimately leading to better model performance with fewer iterations compared to brute force methods like grid search or random search. This technique is particularly useful for complex models or large hyperparameter spaces where manual tuning would be impractical. Additionally, Bayesian optimization is known for its ability to handle noisy or non-convex functions, making it versatile and highly effective in improving the performance of machine learning models. Alright, moving on to the next question. Which AWS machine learning service is best suited for developers who want to quickly build custom machine learning models without any prior machine learning experience? Amazon SageMaker, Amazon Comprehend, Amazon Recognition, Amazon Personalize. Pause and consider the answer before we disclose it. The accurate response is Amazon SageMaker. Now, let's determine why this is the right answer. Amazon SageMaker is the best AWS machine learning service for developers who want to quickly build custom machine learning models without any prior machine learning experience. SageMaker provides an integrated development environment for building, training, tuning, and deploying machine learning models. It includes built-in algorithms, model training, and hosting services, making it easy for developers to get started with machine learning projects. With features like automatic model tuning, one-click deployment, and real-time monitoring, Amazon SageMaker streamlines the machine learning workflow and allows developers to focus on building and deploying their models rather than on the underlying infrastructure and algorithms. This service is ideal for developers looking to accelerate their machine learning projects and experiment with different models and techniques. Alright, now moving on to the next question. Which of the following visualization techniques is best suited for identifying trends in time series data? Bar charts, P charts, line charts, scatter plots. Before we reveal the answer, pause and reflect on it. The accurate response is line charts. Let's now explore why this is the correct answer. Line charts are the best visualization technique for identifying trends in time series data. In a line chart, data points are connected by straight lines, making it easy to see the changes in data over time. The x-axis represents time, while the y-axis represents the values of the data points. By visualizing the data with a line chart, patterns, trends, and fluctuations over time can be easily identified. This makes it an effective tool for analyzing time series data and making informed decisions based on trends observed. Other visualization techniques like bar charts, pie charts, and scatter plots are better suited for different types of data analysis. But when it comes to time series data, line charts are the most suitable choice for identifying trends and patterns. Alright, here comes the next question. What are some ethical considerations to keep in mind when developing machine learning algorithms? Transparency and explainability of the model. Fairness and bias in algorithmic decision-making. Data privacy and security. Workforce displacement due to automation. The answer that is accurate is fairness and bias in algorithmic decision-making. Let's now examine why this answer is correct. When developing machine learning algorithms, it is crucial to consider fairness and bias in algorithmic decision-making. Ensuring that algorithms are fair and unbiased is essential to prevent discrimination and unjust outcomes. This involves carefully examining the data used to train the model to identify and mitigate any biases that may be present. By incorporating fairness considerations into the algorithm's design and implementation, developers can help prevent algorithmic decisions from reinforcing or even amplifying existing biases in society. Additionally, regular monitoring and auditing of algorithmic decision-making processes can help identify and address any instances of bias that may arise over time. Overall, prioritizing fairness and mitigating bias in machine learning algorithms is essential for promoting ethical and responsible AI applications.